So when light reflects, it always obeys the law of reflection. But you notice sometimes, of course, I've got my little laser light here. You can see the light. You can see that laser light reflecting off of the page. Notice you don't see the beam traveling through the air. Here's my hand, and you don't see the beam traveling through the air because as it travels through the air, there's nothing essentially for it to reflect off of. You only see light when it actually enters your eye. And so the light doesn't get redirected into your eye, in this case into the camera lens, until it strikes something to redirect it, which in this case is the textbook page. When I shine it on the mirror, you can barely see it on the mirror. And the only reason you can see it at all is because I have scratches and smudges on the mirror. That's because very little of the light's being redirected into the camera lens. Most of it's being directed, obeying the law of reflection, up onto the ceiling that you cannot see. So it's going in this way and then going out that direction, and you don't see it. So we I know this is really boring, but we're just going to go with it. So we break light into, reflection into two different categories. This is referred to as geometric optics, where when we study the what we call the ray approximation of light, where light travels as a ray. So light's traveling as a ray, it strikes a boundary, and when it strikes a boundary, it either reflects or sometimes it refracts, which we'll get to next, and sometimes it does a little bit of both. But there we can see when light strikes a mirror, it hits the boundary and it reflects away from you. If your eye is over here somewhere, if this is your eye, you're not going to see it because the light comes in and it goes away. Here's how they can draw it. Here's the incident light ray. These are 4 parallel incident light rays, and all the reflected rays reflect away. And if your eye is over here somewhere, you're not going to see these rays because they're not going towards you. That is called specular reflection. Specular reflection is the reflection from a mirror. Sometimes it's also referred to as smooth, S-M-O-O-T-H, smooth reflection, or even regular reflection. But that's when you look in a mirror, that is specular reflection, light reflecting, obeying the law of reflection, and reflecting off of a smooth surface. Okay, like a mirror. Super smooth. This is smooth down at the order of magnitude of the wavelength of light itself. It is that smooth. Remember, the wavelength of light is 400 to 700 nanometers. That's 0.4 millionths of a meter to 0.7 millionths of a meter. It needs to be smooth at that level for it to act as a mirror surface. Over here, you don't see the reflected beam. It scatters all over the place. That's the same as the light that's striking this textbook page. You're able to see this. It's not a mirror, this piece of paper I'm pointing at. But it's all the light rays that hit it, which are coming from the overhead lights in my classroom. They're all obeying the law of reflection. But if you have like 4 parallel incident light rays, like right here, when they strike the paper, if you were to magnify the paper a gazillion times, it's really rather rough. It feels smooth to my hand, but it's rough for a light wave. And so they strike, the surfaces are kind of rough, and when they reflect, they really go all over the place. Okay, they kind of scatter. And that is called diffuse. I know it's kind of hard to read. Diffuse reflection. A diffuse reflector is any kind of light any reflected image that you see that's not been reflected off of a mirror. All right, and when you look at, as you're looking at this page, as you're reading a book, as you look at your friend, you see a door. I mean, anything that's not mirrored, the fact that the light's reflected off it, and you can see it, is diffuse reflection. You'll see a question on the homework about headlights. You see a wet road acts more specularly because the light reflects and is coming towards the camera lens that took this. If you're back in the car as the driver, less of the light reflects back towards you because it's reflecting specularly, obeying the law of reflection. So when it reflects away from you, meaning that it's harder to see the road because less reflected light goes back into your eye because you're back in the car where the light came from. Whereas it's easier to see a dry road because the light strikes the dry road and and reflects diffusely all over the place, including back into your eye. That is diffuse and specular reflection. The other thing I want to talk about is what's it called? Retro reflection. And I'm going to put this on the whiteboard. But I do want to just show a demo. This is not working so well. I might want to show a demo if I can find out where the demo is. Here we go. Sorry. I just want to show you what this looks like. I'm going to have you watch a video on it. So this is a mirror. This also works with prisms. And there are 3 mirrors here, and they're all at right angles to each other. And when light reflects into this, it strikes, you're not going to be able to see this, but when it strikes the mirror, it bounces around inside the mirror. It bounces around inside the mirror and comes right back, because of the geometry of this, it comes right back along 180 degrees opposite the direction that it came in. I'm going to want you to watch a little YouTube video on this in a little bit. But that's how a reflector works, like reflectors on your car, or you might have reflecting clothes or whatever. Like I jog with reflecting tape on my shoes and jacket and stuff. Anyhow, I think I'm going to talk about that on the whiteboard because it's too hard to demo that one. All right, I'm going to stop this here.